Hi, this is Kevin from the Mathsaurus, and in this video we're looking at question 5 of the Oxford Maths Submissions Test from 2019. Don't forget to check out all of the other questions in this playlist and the videos I've done for exams for previous years, all linked very easily from the Mathsaurus website that you can go to from the description below. So I really hope this is useful. Please do like the video if you have found it useful and share it with anyone else you know taking this exam. And do subscribe to the channel if you haven't already, and you'll get notifications for when I put the next part of this series out. So in this question it says we've got to count the number of ways of partitioning a set of n elements into subsets, each with at least 2 elements and at most n elements. Well, we couldn't have more than n elements anyway because that's the whole set, but it's excluding here 1 element or 0 element subsets. So if n and k are integers, with 1 less than k less than n, we're going to let f of n and k be the number of ways of doing that, of partitioning the set into n into k subsets. And they've given an example here that f of 5 and 2 is 10 because we can see all the different ways of splitting just the numbers 1, 2, 3, 4 and 5 into 2 different subsets, and again only subsets that have size 2 or 3 here, because we can't have size 1 and then or 0, and so that means we can't have size 4 or 5 either because they'd have to pair with them. Okay, so in part 1 it says explain why f of n and k is 0 if k is greater than n over 2. Okay, well if there are more than n over 2 subsets, okay, right, so if there are more than n over 2 subsets, right, and each with more than 2 elements, right, then we're going to have, then there'll be more than n over 2 times 2, which is n elements, so it's impossible, right? You might want to write a slightly better sentence than mine there, but you know, that's the idea. If I have, you know, if I've got n over 2 subsets, all of which had exactly 2 elements, then I'd have n, and that could work. But if I've got anything more than n over 2 subsets, each with 2 elements, then I'll have more than, then in total I'll have to have more than the number of elements that I've got in the overall set, so that can't possibly work. Right, part 2 it says what's the value of f of n and 1 and why? Well, okay, firstly just notice that if n equals 1, then f of 1 and 1 is 0, right? Because you know all subsets in the definition of S have to have more than 2 elements, right? So if I only start with a set with 1 element, I can't form any subsets that have 2 elements. But if n is greater than or equal to 2, then f of n and 1 is going to be 1, as there's just one way to form one subset, right? That's to take the whole set. Okay, so if I have a set of n elements and I want to make one subset out of it, the only way I can do that is just to take the whole set as the subset. Right, in part 3 it says in forming an allowable partition of 1 up to n plus 1 into subsets of at least 2 elements, we can either pair n plus 1 with one other element, leaving n minus 1 elements to deal with, or take an allowable partition of 1 up to n and add n plus 1 to one of the existing subsets, making a subset of size 3 or more, and we want to use this observation to find an equation for f of n plus 1k in terms of f of n minus 1 and k minus 1, and f of n and k that holds where k is greater than or equal to 2 and n is really greater than k. Okay, so right, so let's think about this carefully, right? So I've got this set that goes up to n plus 1, and the first way of doing this is I'm going to pair n plus 1 with one element, right? So I'm going to take a subset n plus 1 and maybe 3, say, and make that one of my subsets, and then what I'd have left is 1, 2, 4, all the way up to n, right? So this is going to have n minus 1 elements, right? Okay, so if I'm thinking about f of n plus 1k, how many ways to partition 1 up to n plus 1 into k subsets? Well, there's these n different ways of doing it where I take either 1, 2, 3, 4 all the way up to n and make a 2-element subset, and then I can still think of I've got to make k-1 subsets out of the remaining n-1 elements, right? So, and the formula to do that is f of n-1 and k-1. Okay. Otherwise, we can take an allowable partition of 1 up to n and add n plus 1 to one of the existing subsets, right? So I could, instead of doing it this way, I could take 1 to up to n, right? I'm just going to form this into subsets, right? So maybe I get 1, 2, 3, 4, 5 or something, and then 6 up to n, as long as n is big enough in this case. And now I've got this n plus 1, and I can choose either to put my n plus 1 in this one, or this one, right? So there'd be k different places I could put this set n plus 1, right? So I'd have k different options in this one for each of the different ways of splitting 1 up to n into k subsets. So that would just be f of n k. So, and that's all the different ways of doing it, right? So this is what we call like a recursive formula where I take this problem of splitting 1 up to n plus 1 into k subsets, and then look at two smaller problems, and in theory, if you give me some particular value of n and k to work with now, I can just apply this formula and get a smaller problem, and then I can apply the formula again and get a smaller problem, etc. Okay, and that's exactly what part 4 is about. So if that doesn't make sense, just hang on for 1 second. So there's the formula I've worked out a second ago, and it says now compute the value of f of 7 and 3. Okay, so I'm just going to apply this formula. So for 7 and 3, well, n plus 1 is 7, so that's n is 6, and k is 3. So I'll just plug that in. So n is 6, so that's 6 times f of 5, k is 3, so k minus 1 is 2. And then I've got 3 times f of 6 and 3 there. Okay, now, so what we could do now is take each of these f's and apply the formula again, and keep kind of going down until we get values that we know, right? But notice we already know this first one because this was given to us in the question, that f of 5 and 2 is 10. So actually I can just say that this is 6 times 10, which is 60, and then I'll just apply the formula again recursively here. So this time n plus 1 is 6, so I'm going to do it again with n equals 5 and k equals 3. Okay, so this gives me 5 times f of 4 and 2, just applying this again, plus 3 times f of 5 and 3. Okay, now just notice in this one, f of 5 and 3, right, this is going to be 0, right, as in this case we've got k is bigger than n over 2. So one of the earlier part, which part was it? Part 1 actually, we explained why you can't do this. I can't split a set with 5 elements into 3 sets that have 2 elements. There's not enough elements to do that. Okay, so this bit is 0. Now, f of 4, 2, well, I mean, you could, again, if you want to, you can, apply the formula again until you get something super obvious, or we can just work out, f of 4, 2 here. It's not too hard. How many ways are there to split, the set 1, 2, 3, 4 into 2 subsets? Well, I'd either have to have 1 and 2 with 3 and 4. I could have 1 and 3 with 2 and 4, and I could have 1 and 4 with 2 and 3. Sorry about my bad set brackets there, they're all meant to look like that or something really. So I get 60 plus 3 times 5 is 15 times f of 4 and 2, which is 3. There's 3 different ways of doing that. So 60 plus 45 gives us 105. And in the final part it says give a formula for f of 2n and n in terms of n when n is greater than or equal to 1 and show that it's correct. So the thing to notice here is that if I'm splitting 1 up to 2n into n subsets, right, that means necessarily each subset has to have 2 elements, okay, just because of the number of elements there are here. Right, I'm not allowed any 1 element subsets, and I've got 2n subsets in total, so if 2 is the minimum number of objects I can have in my subset, and I've got to make n subsets, I can only do that by just taking n lots of 2, n lots of subsets of size 2. Okay, so actually, so the number of ways of doing this, right? What have I got to do? I've got to choose 2 objects out of the 2n here, so that's 2n, choose 2. Then I'll have 2n minus 2 objects left, and I'm going to choose 2 of those. Then 2n minus 4 and 2 of those, right? Until, depending on the size of n, some of these terms might not exist, but eventually I'll just get down to having just 2 left, and I'll have, the last 2 steps here, I'll just have 4 left, and it'll be 4 choose 2 times 2 choose 2, okay? So using the formula for NCR, I've got 2n factorial here. I'll think about overcounting in a second, by the way. I've got 2n factorial over 2n minus 2 factorial times 2 factorial, and then 2n minus 2 factorial over 2n minus 4 factorial 2 factorial, and you can start to see the telescoping sort of argument here, or the cancellation, perhaps I should just say here. And eventually I get all the way down to here, and I end up with 4 factorial over 2 factorial 2 factorial, and the last term here, well, it's just 1, but I could write it as 2 factorial over 2 factorial 0 factorial for completeness. You see, the nice thing that's happening here is I get a cancellation in each of these terms, so actually these will all cancel, and what I'll be left with is 2n factorial, and then I've just got all these 2 factorials on the bottom, and there are n terms here, so I just end up with 2 to the n, because 2 factorial is just 2. Okay, so that's almost the answer. The only thing we've got to think about here is overcounting. So if I do this, that's specifying a particular order of the different pairs, right? So I might have, for example, 1, 2, 3, 4, and 5, 6, right? If there was just 6 elements, but this we don't want like 3, 4, 1, 2, and 5, 6 to be distinguished as different. So we can say that this overcounts by a factor of n factorial, right? Because I've got there's n factorial different ways of arranging those n different 2-element subsets by a factor of n factorial. So perhaps I shouldn't actually write f of 2n n here. I should say something like the number of ways of choosing these in a specific order is this. But anyway, I'd get away with this for sure, as long as I've explained this clearly at the end. So f of 2n n is actually 2n factorial over 2 to the n, and I need to divide by n factorial, so I can just put it on the bottom. And then we're done. So I hope that was useful. Please don't forget to like the video and to subscribe to the channel if you haven't already, and check out everything else I've got over at the Mathsaurus website. Loads of other questions from different years that I've put into playlists for this exam, and other things for GCSE and A-level maths as well as the Amazon store that you can find some of my recommendations for interesting books to read that go perfectly alongside sixth form studies and applications to university mathematics too. So I hope that's all useful, and I'll see you in the next video.